session associated with technology. Today we are going to understand the project management methodology, the process, how to understand and deal with the data corresponding to telecom industry, and how do you give solutions one particular problem. So any business problem pertaining to whatever might be the what we can say is the situation, the business problem should be solved, and you have to give a solution for the business problem. Something can be done even before some hazardous situation is going to happen. The situation should not go that worse is our aim. You have to take some proactive action, and that proactive action will help you to make profits, and it will save us from entering into losses. So we are following CRISP MLQ methodology here. This CRISP MLQ methodology is a 6-stage process, and if you follow these 6-stage process, we will complete a problem and we will be getting a solution for that problem. We are going to get a solution for that problem. So it is a CRISP MLQ. Same methodology is used whatever might be the underlying sector. So what is this all about? It is nothing but cross industry standard process for machine learning. And this is your quality assurance. So the point here is, when we are talking about a certain problems to be solved, like yesterday we have seen churn prediction, or you want to do some mining on complaints, or you want to do some predictive analytics, like what will be, how to give a better network outage. Right? Reason is that we have to solve that particular problem, but every problem will have some challenges to solve it. So in this regard now, when we want to work with any of this project, any of the solution for the problem, we need to follow the types of analytics. And these 4 types of analytics, if you are going to do, if you are going to analyze, we are getting a solution for our business problem. We are going to get solution for the business problem. So what is the solution for the business problem? If we have to start with, okay, assume that now you have collected this data. We have this data collected, and we are trying to solve a problem here, like given the customer's complaint, given the date of complaint, the month of date and month and year of complaint, the time, how did you receive this complaint, given city, given a state, given a zip code, as a computer, this complaint status is closed. Is it the tickets are still open? The tickets are closed. Are they solved? Are they still pending? So who is filling on behalf of someone? If someone is filing on behalf of someone, my network, I'm not doing it, someone else is doing on behalf of me, someone else is recording the complaint. Okay? There is no and yes scenario. So this is the data. I want to solve a problem for this, right? I want to know how many closed cases are there, how many open cases are there, at what time the more number of complaints are getting recorded. I want to give a solution so that I want to give a better customer satisfaction, okay, make it something convenient for the customers, so that whatever might be the reason here, I should get the solution, and I have to know what is the rate at which these complaints are getting closed. So I have to perform now 4 stages of analytics on this data. Then I'll get a solution for it. So first, when I got this data, what is that I have to understand here? It's nothing but now I take this, I will look into the data and I'll understand what happened. What is the problem here? Why did you approach, or what is the reason that we have using this data set? For what we are using this? Right? It is nothing but you are working on historic data. You're working on historic data to understand what happened. So what does it happen? So many complaints got registered. They're always coming up. Complaints are registered. Then you have to answer the question why the complaints are being raised. Why that something happened? And why you are getting complaints like this. You will go deeper on what day the complaint has come, right? Whether it was an internet issue or it is through a customer call, which city, right? Why it was not closed yet, why it is still pending. It is called as why that happened. Why people are complaining. What is the main issue of this complaint? This is something what we can do in diagnostic. So many textbooks say that these two will go hand in hand. Complaints got registered. Why those complaints got registered? Maybe because of network issue, network outage, or it is bandwidth issue. That is what we are going to predict. You are going to diagnose and understand. Then you have to predict what is going to happen. What it is going to happen. What is the future? This is talking about predicting future. Right? More number of complaints will be registered. People will not be happy. Customers will get irritated. You are giving a complaint, it is not getting rectified within 24 hours. Customers get irritated here. That is a prediction what you are doing. And finally, you will work with prescriptive. That is nothing but what should be done. It is what should be done. This is your decision making. So you are getting a solution for the business problem. These 4 stages of analytics, they are used in CRISP MLQ, which is project management methodology. Okay, it is a project management methodology. So what happened? Why that something happened? Few textbooks, few of the resources say that these two are one only. These go hand in hand. What happened? Why happened? It is only working with historic data. By decoding this or by finding out the insights, you are going to say that why the customers are getting irritated because of this. So because why? What is the situation? Because the complaints got registered, they are not solved. What you should do? You have to create some process of automation, or you have to improve the network management, or you have to take a call. Why these people are getting irritated? What is the reason? Why the network outage is not happening properly? And what days the network flow is more? On what days the network flow is less? All these things can be understood if you perform this type of analytics. So performing analytics is nothing but getting a solution. So where we remember this as D square, P square. Where we say that it is D square, P square. Order is important here. We take the order here. So we are saying that if at all telecommunication companies, they are not an exception to perform analytics. Right? Even they can use data science. Right? There are wide variety of situations coming up which can be solved to maximize the profit, to build some effective marketing and improve your business strategies. Right? You can visualize the data. So what you can do is, this is all running about your data exchange, data import, data transfer. So the amount of data which is passing through various communication channels, they are getting increased every minute. So the old things what we have, the old analysis constraints what we have, it is not applicable now. It is not applicable now. So once you are able to predict the reason to solve a business problem, right, you can get some valuable insights. To get those valuable insights, we are running behind these two types of analytics. So that whatever insights you get, you can make a better decision, and that decision you call them as data driven decision. From the analysis, if you are trying to predict that yes, in the evening around 6 to morning around 2 o'clock in the midnight, the flow is very, very high. So you have to improve the bandwidth at that particular time. Rest of the time, normal bandwidth would go. Right? So the knowledge of customer preferences and the need to get a better understanding about the customers, predictive analytics will use this historic data to build the forecast. Right? So the better is to do predictions to solve the problem here. Right? So acquiring a customer is a very, very challenging task. On top of it, if at all you are not able to give him proper network coverage, right? Accurate diagnosis of the customer's behavior is to be done. You have to enable the alerts. You have to highlight the risk factors here. You have to impress them by giving smart data platforms. You can bring in the transaction data here and do that. So all these are few things. The main thing is that you want to do is network management, right? There is nothing but you have so many internal channels and those have to be function smoothly. So network management and optimization will give definitely an opportunity, right, to identify the root cause of whatever complications we will face. But looking into the data here, predicting possible future outcomes, it is a great benefit for all the service providers here. Okay, for all the service providers. So on this data, whatever I have, I can perform sentiment analysis. Like people are writing in an angry way, it's just a normal complaint or it is just recorded for giving complaint or they're not at all happy with my service. So it is a sphere where, constant change happens and the increasing role of this internet services, right? It is nothing but a method of processing the information, and that information is nothing but a text data here. This is all text. So taking this data, you should perform sentiment analysis and you have to try to find out which are the most intensive words. So just like analyzing complaints. And the second thing you can do is that you take feedback and you perform analytics on that. So these are the few things, right? So it has to, even now, telecom industry, the steps are being taken. They are also adopting modern technologies and techniques. And they operate with a very, very good infrastructure with the intense data flow. So with the help of few techniques, those techniques we are using here to understand and give the solution for any particular problem. So this is what is this. So we are using these 4 stages of analytics here in CRISP MLQ. So CRISP MLQ process is a 6-stage process. This 6-stage process is nothing but, first, you should know what is a problem, right? And then You have to understand the data. So if a person has come up with some problem, you should be able to know what will be the problem and what you want to predict. You have to understand the data. So if someone comes, he says that I have this business problem, I want to do some analysis on the computer data which is collected from the database, which is given through internet and it is through customer calls also. So he has given me this data. I have collected the data. I'm very, very lucky that the data is collected and it is readily available for me here. So what will I do? I take this data, right? I have very, very small data set, around 2000 data points is what we have here. Given date, time, month, right? How do you receive this complaint? What is a complaint? We are checking all this. Now the point is, when we want to perform this analysis, we should understand this data. So you are understanding that it is a text type of data. It is, a time data. Again, it is a text column. It is some city. You have a status like this. What is that you want to predict and what are the data you have collected? You should understand that. And this data, what you are seeing here, it is totally raw data, raw format of data. See here. You see this data? It's really raw. Right? See here the data. It is having symbols. It will have question marks. It will have all type of symbols. You are having. So what I can do now? I cannot pass this thing to do predictions. I'll only do some analysis on the data that okay, more number of calls are coming from internet, more number of calls are coming from one particular city, Atlanta, or most of the problems are being closed very, very easily. Tickets are not getting raised, all are solved. If city is known enough, state is not required for me. So these few things what I have analyzed. Then what will I do is, when I have to do, I cannot pass the data to the machine to learn just like this. What will it will understand? 22-April 15. You are saying giving time, you are giving date. So such data machine cannot understand. That is, to make it understand, you should perform data engineering or pre-processing. So preparing data, you can call it as data munging, data organizing, data cleansing. You are making it into a format where it should be understandable to the machine, so that machine can understand it and be ready for unknown, unseen data. Okay. So what is it we should do now? Once you got this data preparation ready, we have organized your data, you will ask the machine to learn. How the machine is going to learn? It is going to learn the patterns like this. A ticket being raised via internet from this city with this zip code. On this, see here, both are same, no? One column, okay, you can delete it. That is called as a pre-processing. Zip code is not enough for any analysis, I delete it. City or state, one column I'll keep, I'll delete the other column. So state I'll delete. This is I'm going to do. Okay, and I'll make my machine learn. Given all these details, now I'll say that I have the data like this, which is the ticket raised this, the ticket ID is this. I've received through internet from this city. Is it solved or not solved? Whether it is solved or not solved. That is what I have to know. So like that, if I pass these 2000 data points, my model will learn that and memorize it and learn the pattern. See, from most of them are coming from customer care call. If a complaint is registered in the city and that is pending, it will remember like that. What is a complaint? This is a complaint. It is closed means you will know now which complaints are not being closed. Right? So disconnects every night, internet complaint on horrible internet service, speed. They only left speed. So internet billing and service issues, TV signals blockage. Right? Nowadays it is telecom, it's not only connectivity between the mobile to mobile, source to so other part. It's all that we can understand that it is related to internet, it is related to television also. Right? So once I get this data, I am asking the machine to learn. So machine started learning. Then what will happen? Once you do, if at all you are passing your data, new data, it should be able to predict, right? It should be able to predict whether it is whatever we are trying to predict, it is yes or no scenario. Suppose your predictions went wrong. You did not give a better learning. What will happen? Your model is not good model. Your model is not a good model. At any business problem you take, why will a third party, a client, would trust you? You are saying that, see, I have built one particular machine learning algorithm where I can predict the complaint is registered through internet or through customer care center, or what is the intensity of that particular complaint. I can do that. But tomorrow, when you're going and doing and showing it on new data, how can you trust that particular model? How can you trust that your machine has learned it properly or not? For that, you will evaluate your model. You will evaluate your model. So model evaluation is something which is very, very important. So that you get something called as accuracy. This much accurately a model is working, right? By the customer, they were talking about the convenience of the customer here. Satisfaction of the customer, how convenient he is, how irritated he is feeling, right? How do you prevent him from churning? All these are very, very important. But how can you trust? You are telling that so and so customer is going to churn, but why should any client should believe in you? So you will evaluate, you will say that my model will be predicting 100% accurately, 95% accurately, or 90% accurately. We never trust 100% accurate models here. It's all that we need to understand. But how well it is performing is your stake. How well it is performing is your understanding. So model evaluation and tuning. If your model is not able to give you right predictions, if your model is not giving right predictions, what will happen? No one will trust your model. So what will you do? You have to tune few parameters so that there is a chance that your model may work properly. Once you build, pattern learning happened. But how did it learn? You want to test. So when you are testing, if the accuracy is not up to the mark, you tune and you try to increase this accuracy. Once you feel that the right set of tuning is completed, you go and do a deployment. So it will be a beautiful dashboard like this, given all the details of the customer, churn, not churn. Churn and not churn. This will be your output. You'll showcase the output like this. This is called as a beautiful dashboard, or you can create a web app. This is called as deployment. Right? So we have so many web apps created, right? Airtel gives you a web app. Every particular like banks give us, even telecom industry also gives you according to your network. You can please recharge from this Airtel, right? You can talk about this internet facility or about this network related to mobile data and all that. Do you think once you have given this data and you're able to say that so and so customer, the complaint raised 4 times, it was not closed, he is ready to move to a different network. So the Airtel say Tata or Tata say Airtel. They're about to move. So you are able to build this model and it is kept ready. But how can you ensure that this model is working fine every time, 365 days and all the time? Because when you have predicted or when you have given training, it is one set of training what you have given. But every day data is new, data is getting added up, data is going to increase, and we have huge variety, volume of data here, variety of data here, which is very, very big problem. So once you do deployment, a beautiful web app, it's created, you have to keep on monitoring it and you have to do particular maintenance to it. Okay, you have to do a particular maintenance to it. Okay, that is nothing but monitoring and maintenance. So it is not a single go, one stage go. Every 3 months or every once in 3 months or 6 months, you have to update. You have to accept the changes here. How do you do that? You have created a chatbot for your app. Airtel app has created a chatbot. You are asking on a single day 300 questions is what is accepted. Right? Tomorrow when you are receiving messages more than that, what will happen? Your chatbot will not respond. It gets hanged out. Why? Because it has a habit of answering only 300 questions. Tomorrow you are giving more number of questions, which is very, very big problem. So what you will do when you are trying to do this, right? Your chatbot requires some upgradation. There's something called as a PEST, right? Political, economical, social, technology. Anything can be the reason for the change in the data, increase in the data. So you keep on monitoring and keep on doing maintenance for your model, whatever you have deployed. It's not a one-stop process. It is a continuous process. The solution is what you get here by the time we complete the 4 stages of analytics. After you complete this, you get the best model. You go and do deployment. So deployment is done using a Flask applications. Okay, and that deployment should be not every time, but at least once in 3 months, you have to keep on monitoring it and do the maintenance for that. So this is the structure. These are the steps what we are following. So you understand it, you collect the data, you understand the data, you prepare your data, you build your model. If your model is not able to understand, again you go back, you do would take your 80% of the time. The rest of the steps here is 20%. So to understand the business problem, to collect the data, to do data understanding, and you prepare the data, 80% of the time is here only with this. The 20% of the time will be taken for building a model. It's a single line of code to build the model, to make the machine learn the patterns, right? And after that, you feel that the right set of parameters have been done, you have to do evaluation and deployment, right? If your model is not working, you tune it, you test it, you tune it, you test it and you tune it, right? So this is the crisp MLQ architecture, or we can say the 6 phases, right? So out of which now let us understand how we are going to solve the business problem. How do you understand the business problem? So what is that which is very, very important here? When you are trying to understand the business problem, if I just write a statement pertaining to understanding the business problem, how we are doing that? Suppose client has approached you and you have to solve this particular problem. He has approached you to solve this problem. He says that my company right, it want to prevent fraud by using big data and to review the source, right, to review the source of transactions, right, and to review the cost of the call, right? How do you give me a solution for this business problem? If my company, some XYZ company, it want to prevent fraud and is asking that he has the data collected and he want to know what is the source of transaction, what is the cost of the call, and what is the destination number. I'll add one more. And all these things, assume that it is happening. Fraud means it is real-time application. It's a real world situation. He has come up with business problem. So what will you do? You take the data, because he is saying that he is having big data, right? This big data, it is there in the database. He has given you the data. You take this data and a bunch of data scientists would work and you would build a model. And you will be able to say that whether the transaction is a fraud transaction or it is not a fraud transaction. Security concerns is something what you're talking about. So what is that you have to do now when it is saying that it is a fraud and not fraud? And for each and every transaction, you are saying fraud, fraud, fraud. You're predicting that it is a fraud. Right? So what will happen? People will not, everything is a fraud transaction, and your team is saying that it is a fraud, right? You are stopping their transactions. You're stopping their transactions. Definitely, people will not use your network. Definitely, that particular company's network is not used by any one of them. Right? So what will you do? You want some smart solution, and you will say him, you will give him solution that, sir, these are the people who are fraud. This is not a fraud transaction. You can predict this. I have used Python here. This is a solution. You are able to predict whether it is a fraud or not. So based on this, you can stop the transactions. But if every transaction is a fraud transaction, your model is built like that. Most of the transactions are fraud transactions, right? People get irritated. They think that there is no security with my network. I'm not able to give proper network to them. I'm not able to give proper security, privacy here. They will definitely go and churn. Right? So you cannot say every transaction is a fraud transaction. My aim is, I know that it is a fraud transaction, but my aim is I want to minimize those fraud transactions. You are predicting and telling me that these are the fraud transactions. Definitely yes. But if you are stopping their transactions and the network is not good enough, the security concerns are coming, people will definitely churn. This is even more worse situation. So what you have to do is, I want a solution where you have to keep in mind the convenience of the customers. You have to even keep in mind the convenience of these customers. Come up with a solution which will toggle in between these two. So what are we doing and trying to understand here? Whatever the transaction source is there, or which app they are using, you should have a security concerns not only from the app side, it will be there from your network side also. Right? You should be able to know. Right? You should be giving proper security and privacy. So what will you do here? Any business problem, you have to record what is the aim. At the same time, you also have to record the limitations. Right? You also have to record the limitations, and your solution should be there in between these two. These are nothing but constraints. These are called as constraints. Whether it is the aim is to increase the network, decrease this network outage, or to give a very good chatbot, whether to optimize the automation things, whether to prevent churn or not churn, right? You want to prevent this churn prediction, or you want to minimize the fraud. Whatever might be the business problem, you want to improve and get a good network bandwidth. Okay, whatever might be the business problem, every problem will have certain limitations also. Right? Every problem will have certain limitations which you have to accept them, and accordingly you have to work, and accordingly you have to give a solution, because any solution you are trying to give is not accepted by the client. Absolutely, they are not going to accept. And every business problem, when you are solving, you are going to get bunch of challenges here. Okay, you are going to get transactions here. Those transactions should be minimized, exactly, which are fraud. I agree, but what is that you should do here? According to that, also you have to face all the challenges and then help them here for solving those business problems. For instance, now you want to decrease this fraud, or for an instance that you want to predict network outage, you want to increase the availability of service, or you want to automate call center service desk, or you want to know the utilization of network bandwidth so that you can give more optimized plans. Right? So whatever might be the problem, whatever might be the situation here, so what is that you are going to do? Any service desk, any manual process you are trying to do, that is a problem statement, and that should react properly. So the manual process of routing the incidents received from the customers to the appropriate server is very, very important. Right? So you want to do it with the resolver groups. Introduce questions in your chatbot. Right? So what will happen? You have to solve it. So Reaches has shown that the significant amount of time is spent in reassigning the incidents to correct the resolver groups. So what is going to happen now? Enormous service desk staff is important here. So service desk is one of the process. It's the manual process. You're routing whatever complaints, or I can say whatever incidents you are getting here received from the customers to a particular group. Inappropriate use of people should not happen. Particular group should solve that particular problem. And if at all this group, you are not routing it to the right group, right, this activity will definitely go worse. Right? And this manual process is only because of human error. People are not routing to the right group of people to solve the business problem. So research has to be done that significant amount of time is spent to reassign these incidents correctly to the correct solver groups, which were inappropriate earlier. So the risk of missing the service level agreements or paying huge penalties for the slippages is a very, very big problem here. So you are not at all resolving the problem because of the routing is not happening properly. Your business problem solution is not happening properly. So enormous service desk staff is needed for assigning tasks properly. So what will be the challenges here? Complaints are getting registered, tickets are being raised, no solution for that. So you want enormous service desk staff for assigning the complaints to appropriate department. Which department, what is the complaint registered to? So if at all you have incorrect assignments to different groups, because of the manual procedure, this is going to happen. Incorrect complaint to the routing it to wrong person. So manual process is something wrong, and you are getting huge number of customer calls, call center calls, and via through internet also. So what is happening? It is leading to decrease in the customer satisfaction. So due to, because the time is getting wasted, high resolution time here, delayed in solving these incidents, passing it to the appropriate group. So here in this process, a lot of manual effort is what is required to identify the top issues pertaining to different applications which are getting supported. So what is a solution you can give for such a problem? You want to create a process to get automated. You build a classification model. You can build a classification model, machine learning model, which will scan all the mails, all the customer calls, sort them, then automatically assign them to respective group. Automatically it should go and sit in that respective group mailbox. So whatever we are seeing, the data, it's text data. The ticketing tool where the tickets are getting raised, it will run and it will identify the top issues in this particular model. So you will do a kind of data mining, text mining on text data to solve this particular problem. So what is happening now? How will you improve your business if you create a solution like this? Right? This is an optimized utilization of service desks. You can use service desks in a very, very good manner. So then you are able to reduce the resolution time, or I can say reduction in resolution time. So due to assigning of complaints to two different or inappropriate resolver groups, right? So definitely this will increase your customers' convenience, or you can say satisfaction. And because of the model building, what you have done, manual effort has come down. Manual effort has come down, right? Drastic reduction in this time, right? This is how we are going to solve it. So if at all you want to stay in the competitive world, you have to adapt to the changes what you are going to get. So for any instance we take, we need to solve this in this fashion only. This is how we have to solve. For any business problem, this is the solution. For any solution, that solution will not be accepted by the client. So he will put some constraints on us. So you have to record aim, you have to record limitations. You need to optimize things here. So researchers suggest that use optimization terms. Either you use minimize, either you use maximize. You want to maximize the customer satisfaction, you want to minimize the churn, whatever might be there, right? You record the constraints, you record the aim. All this will be recorded in a project charter, which is a high level document. Your challenges, your timelines, your constraints, right? Whatever error blocks, all these are recorded in a project charter, right? Which is a high level document and duly signed by the sponsor, which is signed by project sponsor, right? So for any business problem, we have to record this in the project charter for getting the solution for that particular problem. So you have to use minimization or maximization, and you can use bunch of models here to solve the problem. Right? So you are trying to do all the how do you increase the availability of the services, right? How do you prevent this people from this customers frustration, right? When you are unable, your network is worse, definitely the frustration would increase. So what is the problem here now? You don't want them to get irritated, so you have to even before the customer complaints registered and the ticket is raised, right? You have to give them a message that there will be a downtime alert. You get, right, proactive messages will be coming. Tomorrow there will be a service issue. Please be careful. The network is not available. You get a personalized message, So you can assume that the client situation, if the unavailability were only due to the network outage, any company cannot guarantee quality of service if they cannot identify this outage upfront. So you are connecting with various geographies and you are trying to find association here to know all the kilometers around, and you're predicting the malfunctioning of that particular network, which is a very, very tough job. That is also a business problem there. So how do you understand what are the challenges? If at all you are maintaining good network outage, cost is something which is very, very high, right? And frequent faults are occurring, you have to do maintenance, right? You have to identify the vulnerable locations, right? So limitation is that you are unable to analyze a huge log files to extract meaningful insights. But any solution you give is again not accepted. He'll say that this I cannot accept, that I cannot accept, because there's a challenges here. These challenges are nothing but the constraints what he's saying. Maintenance cost I'll not improve. Okay, I cannot improve this, but I should find out the vulnerable locations within the maintenance. What am I doing right now? Right? I cannot increase any operational expenditure here. Any faulty equipment also, only to certain extent I can do that replacement. Right? If at all you're identifying the network components also, right? I can only spend this much amount on equipment repair. So he will say all this. If at all you are giving him a very, very good solution also, you will say that, yes, we'll do this, we will build this model, we will do constructive monitoring, we'll live stream the data, we will catch hold of this bandwidth length, we will do survival analysis on that to determine how many days the network operators are failure is happening. All these things you will do, but he will not accept the solution that easily. He will say that, see, these are the constraints what I'm putting on you. You come up with a solution where you can solve it within this one. So customer satisfaction is important, but you have to clear this network outage within this much amount only. This much amount only I can spend. If at all you want to do constant monitoring, you want very, very high resources. I will not pay for that. So that's where data scientist job comes into picture. That's where data scientist job will be coming into picture. So this is how the data looks like. This is how the complaints will be registered. This is the data what is written for different cities. And on this data you analyze and you give a solution according to the interest of the client. So that's where is our business understanding. So you are collecting different data here now, and that data looks like this. Right? To identify anomalies in this data, now this is a text data, you can identify on this. You can also identify how many are received via internet, which city, right? This and this you can link up, right? You can say that on what day, right? If at all you apply some time series data on top, analysis on top of this, you would know that it was a peak day, what was the occasion, whether it was a rainy day or it was like storm day, what it is that there's huge network problem in that particular area, on that particular day, in that particular month. These all are nothing but doing analysis and getting a solution for this problem. But whatever solution we are giving, that also should be accepted, right? So the amount he's going to spend, the constraints what he's going to put on you. That's where it comes into picture the data scientist job. Okay, so tomorrow we are going to see how do you do this descriptive analysis and how we are going to understand the data and how you are going to pre-process it. And how do you pre-process it? So thank you all for joining in. Thank you.